So the first, or not first, but one of the most well-known ocean citizen science projects was caused by an accident in the North Pacific. There was a container ship on its way to the port of Tacoma that happened to lose a container over the side that was filled with 300,000 rubber bath toys. So as these toys made their way around the Pacific, they started washing up on beaches, and people are wondering, well, where are these bath toys coming from? Because it wasn't just one at a time. You were finding bunches of them at a time, and people are wondering, where are they coming from? And so the average citizen, the people that walk the beaches every day, were finding these bath toys and started to report them and trying to figure out, well, where are they coming from? So this was in a partnership with a researcher at the University of Washington, found out about this and said, okay, let's figure out what's happening. And so this is how this map was created. We're able to look at ocean currents and sort of confirm how they move, but also the timeline in which they move. So how long it takes something to float around the ocean. In the United States, one of the more famous citizen science programs is the Audubon Society's Great Christmas Bird Count. So every Christmas for the last 112 years, people have been out counting birds. And this is something that anybody can do. And these last two examples have been primarily adults involved in doing this. But my passion, my interest, is here in the Monterey Bay area, working with the Pacific Grove Museum's LiMPETS program. It gets middle school and high school students out to the tide pools and to the beach to monitor Pacific mole crabs and algae and invertebrates. And I'm not trying to recruit them all to become scientists, but I want them to understand how science is done and start to understand the vocabulary of science. So before students go out, they get training in their classroom to understand the monitoring methods used at their site. And these are a couple of maps of the locations where they monitor. So on the left are the sites where they do monitoring for the Pacific mole crab, and on the right are the rocky intertidal monitoring sites. So you can see they cover a very large area of California. For sand crab monitoring, students use cores, sieves, and calipers to collect and measure sand crabs, and they also tell their sex as well. So that picture on the bottom right is actually a female sand crab with eggs. For rocky intertidal monitoring, they take quadrats, the little squares there, to measure an area of the rocky intertidal. So they're looking at algae and invertebrates, and they get a picture of this. When they go back to monitor, they are looking at that same picture over time. And so the sites, they use those same sites every time. After they've been out in the field, they go back to the classroom and they enter their data into an online database that's been going for about 10 years now. And there's graphing tools on there that they can use to analyze their data. The LiMPETS program was actually started through the National Marine Sanctuaries here in California as a way to engage students in field science, but also as a way to collect usable data. So they found that students are able to collect data as accurately as any professional when given training. But why are they out there collecting data? And this is one example. A few years ago, the Costco Busan hit the Bay Bridge up in San Francisco and leaked just over 50,000 gallons of oil into the bay. And because LiMPETS had students out monitoring sites before this happened and after it happened, they were able to look at the difference to see what effect this accident had had on these environments. But also, we're able to see how those habitats are making up the difference now. Like, how are they changing? How are they responding to this long term? And another example is down in Santa Monica Bay. There was a sewage spill. They spilled about 2 million gallons of raw sewage into Santa Monica Bay. And because that's a health hazard, you now have trucks full of bleach water driving up and down the beach to kill any bacteria. But you can only imagine what that has done to the marine organisms that live there. The LiMPETS program has been able to help with the California marine protected areas that have recently been designated. Some of our monitoring sites are inside those areas, but some of them are outside those areas, and it allows the state to use that data to compare to see if those areas are doing their job. Are these marine protected areas effective? But this isn't just about the science. This is also about the students that we work with. Many of the students that we take out in the field, this is their first time to the beach or to the tide pools. And so it's inspiring to me to watch a group over the course of the year get to know a place. They start to understand the populations that live there, the animals, the algae, and they really take responsibility for this site, take ownership, and become stewards for this place. It's also a chance for them to unplug. For many high school students, as you guys know, they're plugged in all the time, be it cell phones, TV, computer, video game. They're plugged into some sort of electronic device all the time. And this is an opportunity for them to dig into a project and really get involved. I was talking with one of the teachers that I work with, the LiMPETS program, a few weeks ago about the students in his class. and about their attention spans, and that their attention spans aren't as long as previous classes that he's had, and that has changed how he has to teach science and how the students are learning science. And they just don't seem to have the ability to sit and focus as long as they should be to be able to get to know a place. And this isn't their fault. This is the world they're brought up in. I mean, we all are. We all are connected to some electronic device more often than we care to admit. So during Rocky intertidal monitoring, we're asking students to look at a half-meter square for about half an hour. That's about how long it takes for them to accurately count 32 different species of algae and invertebrates. And for a lot of the students that I work with, they can't do it without being redirected by their teacher, by me, or even another student in their group to come back and focus on finishing counting what they're looking at. And it's a challenge, and it's shocking to me, but this is an opportunity for them to work on that focus. The next thing is about being a naturalist. Students are able to become naturalists to understand a place, and there are researchers here in this area that many of you know, and some of you know well, that are really good naturalists in their field, and they understand what's going on in a place. And it has allowed their research to have a richer context because they know the natural history. And for my generation and the generations coming after me, we've been taught the pure science and hard research so much that we don't necessarily have the naturalist skills that I think is necessary to have successful science. And I wonder if our research, the research of my generation, is going to be lacking because of that lack of natural history knowledge. But in the last year that I've been working with the LiMPETS program, I've seen some amazing things with the students that I've worked with. I've heard stories about how they've brought their families and friends back to the sites to teach them about what we've been doing. But also in the field, when you have a group of 30 students with a bunch of science equipment all over the place, you start to pique the interest of the general public walking by. And they will come over and ask, and it's a point of pride, and it inspires me every day to watch these students confidently be able to explain what they're doing and why they're doing it to a complete stranger. So it's what gets me excited, and I really truly love what I do.